Hello guys, my name is Spyros Katsios and today I'm going to show you a way to handle your search request. It's not the right way, it's not the best way, it's just the way that I like to use. I believe it's very clean and abstract enough so you don't have to repeat yourself or write duplicate code. So with that being said, let's go to our project. In my entities folder I have a customer with a first name, a last name, and because it inherits from the domain entity, it also has an GUID as an ID. In my persistence folder I have an AppDB context with only a DB set of customers and an abstraction for that. In my program.cs I have registered my AppDB context with its AppDB context implementation and also mediator. Now in my requests I have a search request that holds four properties: a nullable string sort by, a nullable string sort order, a page size and a page number. In the constructor I check if the sort order is null or empty, and that's actually an extension method for any string that just returns the result of string is null or empty. And I check if it's null or empty, and if it is, I set into ascending. I have a constant class, and I should have made that static, with an ascending sort name and a descending sort name. Now for your sorting you can use anything. You can bind into your sort by string, which is the field that you want your order by. So you have that field plus something else to indicate the sort order. I choose for this example to have a separate parameter, and I use that strings that I just showed you. Also in the page number I do a check if it's smaller or equal to 0 to have a default value of 1, and in the page size, if it's bigger than 20 I set it to 20, and if it's smaller or equal to 0 I set it to 10. So in my example I don't allow page size bigger than 20, and I have a search customer request that inherits from that search request, and it also accepts a first name and a last name, so we can search customers that they have that first name and that last name. And finally in my responses I have a page response which will have an IEnumerable of our items, a current page, a page size, a total count, total pages, and two boolean values that indicate if there is a previous and the next page. Pretty trivial stuff. So now let's go and see how we can handle that search customer request. Also, I forgot to mention, in my controllers I have a customer controller, I inject a mediator, and I have a get endpoint which accepts a search customer's request, and for now it just returns OK. So let's go and see how we can handle that request. First of all, let's go to our queries and let's create a search customer query. So search customers query. And let's fix the typo and also make that a record. Okay, and we will have a first name, a last name, a sort by, and I also forgot to mention I have an enum for the sort order, because I like to use enum for sort order anyway. So we'll have a sort order enum, so let's call that sort order. And the page size and the page number, so page size and page number. Okay, now I'm going to create a folder called filters, and down here I will create a search filters record. And those will be our base filters, some filters that each search request will have, either if it's customers or some other entity. So it will hold a sort by string, a sort order enum, a page size, and the page number. Okay, so now we can go back to our search customer query and have that inherit from the search filters. So search filters, and we will pass the sort by, the sort order, the page size, and the page number. Now I'm going to create a base filter class, so base filters, and that will be a static class. And in here we will apply our base filters to our customers or whichever entity we want to apply the base filters. So I will create a static extension method, so public static, and it will be an extension method to an iQueryable of t, because as we said, it's not bind to customers. And I will call that apply base filters. So this iQueryable of t, let's call that data, and also we'll have the search filters, let's call that filters. And now, because we have a string that represents the property that we want to sort our data by, I will say that that t needs to be a domain entity, because if we use that string to order our data, then we want to order them by a key, and that will be the ID. I have a video dedicated on that, and then I will post that on the description below if you want to check that out. So in here, all we need to say is that if the filters sort by is not null or empty, so if it's null or empty, and we will negate that. Now we will switch on the sort order, so data equals with filters dot sort order switch. And now if the sort order is ascending, we will say data dot order by ef property, and that's an object, and we need to pass that, and also the filters dot sort by, and we know that's not null. Again, if you want to see how you can use strings to order your data, that's on the other video I just mentioned, so I won't focus on that here. And then let's say then by ID. Okay, and let's copy that, and let's say if it's descending, order by descending. And let's also add a default case, and we will throw a new unreachable exception, since our sort order is supposed to be only ascending or descending. Okay, else let's have a default case, and let's order them by their ID. So data equals with filters, and let's copy that. Okay, finally let's return our data, and we need to skip the filters.page size minus 1 times filters.page size, and to take the filters.page size, and we are done with that apply base filters method. So let's go and do the same, but that time that will be specific to our customers. So let's create a customers filter class. So customers filters, and we will have a public static iQueryable of customers, and we will call that of customer, I'm sorry, and let's add the namespace, and we will call that apply customer filters. And this will also be an extension method, but this time to the customers iQueryable. So iQueryable of customer, let's call that customers, and we will also and let's make the class static so you can have an extension method in there. And now we will accept the search customers query. Set customers query, let's call that query. And now let's check if the first name or the last name has any value. So if query.firstname.is null or empty and negate that, then our customers equals with customers dot where the first name contains the query dot first name, and that's not null, we just checked it. And let's make the same for the last name. And finally let's return our customers. Now we'll also need something that the search customer query will return, and that's something that we want finally to map it to our page, the response. So I will create a new folder, I will call that results, and in there I will have a paginated list. That will be a generic class, and it will inherit from the list class. First of all, except of the items themselves, we will need some metadata, for example the count, the total pages, etc. So I will create in here a record, and I will call that metadata. So public record metadata, and it will have a current page, a page size, a total count, total pages, a boolean called has previous, and a has next. Okay, so that paginated list will have a metadata property, and let's create a constructor. In the constructor we will accept the list of the items, a count, a page number, and a page size. So let's initialize the metadata in here. So data equals with new metadata. Let's pass the page number, the page size, the count. For the total pages we will use the math.ceiling method, which returns the smallest integral value greater or equal to the specific number. So for example, if we divide our count with the page size and the result is 9.2, obviously we don't have 9.2 pages, we have 10 pages, but the last page will have less items. So let's say math.ceiling and let's divide the count with the page size, but let's cast the page size to a double. So page size, and let's cast all that to an integer. For the has previous, let's take the page number if it's greater than 1. And for the has next, actually we're going to use the total pages, so let's extract that to a variable. Let's call that total pages. Okay, so in here let's check if the page number is smaller than the total pages. And finally let's add our items and we are good to go. So now let's go and complete our search customers query. That now we need to implement the I request. So I request of paginated list of customers, and let's create and its handler. So public class search customers handler, and that will implement the I request handler of search customers query and the paginated list of customer. Okay, let's inject our DB context. So private read only I app DB context. Let's initialize that through the constructor. And now all we need to say in here is let's take first the customers queryable. So customers queryable, and that will be our context dot customers, let's say as not tracking, since we just need to read the data. And then let's apply our customers filters, and all we need to pass in here is the request. So now let's return a new paginated list of customer, and for the items all we need to do is in our customers queryable to apply our base filters. So apply base filters, and again we will pass the request and to list async, and let's pass the cancellation token as well. Now for the count, we need the customers queryable dot count, so count async, and let's pass again the cancellation token. And finally the request dot page number and the request dot page size. And let's make our method async, and let's await that count async as well. And I think we're good to go. And now if you have another entity, for example search employees handler, all you have to do is to implement in the filters folder a new employees filters, as we did with customers filters, that will be specific to the employee entity. And then you would have another handler, and it will be as simple as this one. You would take the employee queryable by applying the employee filters, And then for all the items you would also need to apply the base filter so you can do the paging, the sorting, etc. So let's go and see that in action. Let's go to our customers controller, and we're going to need some mapping to map the requests and the responses. So let's create a folder, call that mapping, and let me copy and paste the mapping that we need to do. Okay, that's a customer mappers. We just map the search customer request to the search customer query and the paginated list to a page response. You could also add some mapping for the customer object, but I won't do that for simplicity reasons. So let's go finally back to our controller, and in here let's take the paginated list. So let's say var customers equals await mediator dot, and let's convert the request to the query. Okay, and now let's return okay, and let's map our customers paginated list to a customers page response, so to page response. Let's debug that, and I will open Postman. I have already created the request, so if I go and send that, we will get an empty list. That's not right because I had populated my database with some data. So let me check this out very quickly. And okay, in our base filters, in the skip, instead of the page number, we set the page size, so that would be filters page number -1 times the filters dot page size for the skipping. So if I run that again and I open Postman again and I hit that endpoint again, as you can see, we get back some customers, and if I say that I want the page size to be 2, we get 2 customers, the page size is 2, and the total pages are 5. If we want the first name to be John, we get that customer with the Joe first name. If we want to sort by first name, we have our items sort by the customer's first name, so Alice, Bill, Bob, all the way down to Tom. And if we need the sort order to be descending, that's the other way around now: Tom, Sue, Sam, Sally, Mary, all the way down to Alice. And that was it. That's a way I like to apply my search filters. If you have something to add or didn't like something, please tell me in the comments below. If you like this video, please like and subscribe. Thank you for watching and have a nice one.